Okay, good morning. Welcome. We're going to tackle the first question of the 2019 FRQ practice exam. Um, all right. It says we have a rate at which cars enter the parking lot modeled by E of t. The rate at which cars leave the parking lot is modeled by a differentiable function L. Selected values of L of t are given, and they're both going to be measured in cars per hour. T is measured in hours after 5 a.m., which is going to represent T is equal to 0. And both functions are going to be defined between 0 and 12. So basically from 5 a.m. to 5 p.m. What is the rate of change of E? All right, so keep in mind that we have a calculator for this question. And because they're asking us to find the rate of change, that's talking about a derivative. All right. And because we do have a calculator, we're going to quickly get the derivative by doing math 8. So save yourself some time because this question is worth only 1 point. Don't take 5 minutes trying to take a derivative and plugging in the value. So just take your calculator and do math 8. The calculator setup is going to be something like this. It's going to be d dx of E of t. You're going to plug in your whole equation. 30 plus 5 x minus 2. Again, this is something you don't have to show on the test yourselves. You can I'm just showing you what you're going to see in the calculator. X minus 5 e to the negative 0.2x at x equals 7. But in reality, what you guys have to show is just basically say e prime of 7 equals, and then give your answer, which is 6.165 cars per hour squared. The question does say that you have to indicate the units of measure. Without the units, you're not going to get the point. This is just 1 point. How do I know it's cars per hour squared? Because E of t is already cars per hour. So if I take a derivative, you're going to be adding, basically another per. So cars per hour per hour. B. How many cars enter the parking lot from 0 to 12? Give your answer to the nearest whole number. Figuring out how many cars enter the parking lot, it's basically talking about calculating net change. And to calculate net change, we're going to have to integrate. So we're going to do the integral from 0 to 12 of E of t dt. Plug it into your calculator very carefully. Don't miss any parentheses or any negatives, because if you do, then the whole thing's going to be wrong. Also, don't forget to write dt. That's a part of your integral, a part of your integrand. If you do everything correctly, we're going to get 520.07. And then you're going to say 520 cars enter the parking lot. From t is equal to 0 to t is equal to 12. That's it. You get 1 point for setting up the integral, because you're showing what you know. You're showing that you know what to do. And you get 1 point for getting the correct answer. Round it to the nearest whole number. C. Use a trapezoidal sum with 4 subintervals so we can approximate the integral from 2 to 12. All right. So we're going to say that the integral from 2 to 12 of L of t dt equals, it's going to be the sum of 4 trapezoids. So first off, you have to know your formula for trapezoids, which is a plus b over 2 times the height, plus a plus b over 2 times the height, plus dot, dot, dot. Now, normally a trapezoid looks like this, where this length is A, this one is B, and here is the height. But a lot of times when we're doing the trapezoidal sum, especially from a table, your trapezoids are shifted. Think of your trapezoid like this. Slanted. Here's the y-axis, here's the x-axis. So your A is technically a y value. The B is also a y value. And the height is the distance of x. So for my trapezoidal sum, we're going to have 40 plus 15, which again are y values, divided by 2 times 3, plus 24 plus 40 divided by 2 times 4. I'm going to need more space here, so let me scoot this over. Plus 68 plus 24. Plus 18 plus 68 over 2 times 2. Is it 2? The last one? Let me see. Oh no, the last x value is 1. I couldn't really read my notes. But yeah, I mean, you still have a calculator with you, so just carefully plug everything in. And that's going to give us 345.5. You can approximate this value by rounding, or you could just state your answer in a decimal. It's going to be fine either way because we're not told to round. But you're going to say approximately 345.5 cars leave the parking lot between t is equal to 2 and t is equal to 12. That's your answer. You get 2 points for this question. You get 1 point for the trapezoidal approximation or the setup, and you're going to get 1 point for your answer. Okay. The last part. From 0 to 6, $5 are collected from each car entering the parking lot. From 6 to 12, $8 are collected from each car entering the parking lot. How many dollars are collected from the cars entering the parking lot from 0 to 12? Now, since the fee is different for different time intervals, we're going to have to set up 2 integrals. We can't just take one integral and like multiply it by 5 or 8 or 13. You want to take the integral from 0 to 6 of e of t dt, because that's going to tell you how many cars enter the parking lot from 0 to 6. And remember, you're going to be charging $5 per car, so you can already multiply it by 5 as your setup. Then we're going to be adding the amount of cars that enter the parking lot from 6 to 12. And we're going to multiply it by 8 because we're charging them $8 as they come into the parking lot. If you do this setup correctly, you're already going to get probably 2 points. One for the integral and one for the limits of integration with your constants. Just don't forget the dt. Every time you write an integral, you have to have a dt, a dx, or whatever variable you're going to be integrating with respect to. Okay. Take your calculator, plug it in, and you get 3,530. $3,530 are collected from cars entering the parking lot from t is equal to 0 to t is equal to 12. Notice how when I state my answer, I'm basically just taking the question and rewording it, right? $3,530 are collected from cars entering the parking lot from time t is equal to 0 to t is equal to 12. That's going to be probably the best thing you can do. Take the question and restate it as your answer. But yeah, that does it for question number 1. Thank you very much. I'll see you again for the next one.